Did you say number 5?
It was either 5, 6, or 7.
All right. Does that look familiar? Equation of a plane through 3 points?
Won't you have to do 2 vectors
Mm-hmm.
and do a cross product?
Yep.
And then the magnitude or?
No, we don't need magnitude. We just need to make 2 vectors and cross them.
I think they want a specific point, specific.
They might want a specific format. They might want your final answer in a specific format.
It was like,
And if you're not sure of the format, I'm going to go through review an example really fast all the way to the end just to see the format that they've put their final answer in.
I think it was standard.
So yeah, ax plus by plus cz equals d.
I think mine is just somewhere I'll get it wrong. I don't know where exactly it's at. It's like, because like this case, or the last one I did, you had to subtract the 2 because you get PQ. You had to subtract the A's, B's, and the C's.
Mm-hmm.
Then do the cross and then do the same thing with a PR. Then
Yep.
do the cross products.
Yep.
And then somehow when I go to put my final answer in, it says it's wrong. I don't know where exactly I'm messing up with that.
There is a lot of tiny little calculations in here, and a lot of them are subtracting with negatives. There's 2 suggestions I can make to help with this. Number 1 is to write down all of your steps. Try not to skip steps. And number 2 is use your calculator. If you know that you tend to make mistakes, I would type these in the calculator. And that might sound silly, but if you've got to do vector PQ, type in 1 minus negative 5, just to save yourself from making the mistake and having to do the whole thing over again, you know? It might be worth the while. But also write it down. That way, if you have to go back through, you can find where the mistake was. Did you write down your 3 points?
Yeah, I got PQ and R.
All right, I'm gonna go through with your 3 points here real quick, and we can maybe see where the difference is. What's your P?
4, 5, 4. Q was -2, -4.
All, did you say all negatives?
Yes, ma'am.
Okay.
I have all my R. I am missing 1 with R.
All right, let me see if I can go back into.
I got 4 up too.
But the first 2 points I have -2 and 20.
Oh, I don't think that's what I wanted to do. Oh, yeah, it is. -220. So this is number 5 on the homework. If you haven't done it yet, due tonight at midnight. They want us to find the equation of the plane through those 3 points. So we did not do an example like this in class last time, but we talked really quickly right as we were finishing up talking about planes on how to do this problem. To write the equation of a plane, we need a point and a normal vector. And all 3 of these points are in the plane right now. So like Arturo said, we've got to make 2 vectors in the plane using PQ and R. And then if we do a cross product between them, that will give us a vector normal to the plane. So it doesn't matter which 2 vectors you make as long as all 3 points get used. You can't make PQ and QP. R has to get used in there somewhere. So I'm going to make PQ. That means I'm going to do my Q's minus my P's. And like I said, if you find that you know what to do and you know the steps you're supposed to do, but you still keep getting these wrong, I would just make sure you're not skipping any steps and you're writing all your steps down. And you may even want to use the calculator to do a lot of these addition and subtractions. As you get into more and more advanced math, that you think the easier stuff is so easy, we just do it quickly, but that's usually where the mistakes are. So you might even just want to type some of that stuff into the calculator. So the Q's minus the P's, that's going to be -2 minus 4, which is -6. -2 minus 5 is -7. And -4 minus 4 is -8. You also could have made QP, and that would have worked just fine as well, and they would have just all come out positive. And then we also need to make either PR or QR, or RP or RQ. We need another vector that has R in it this time. And it doesn't matter what it is as long as it contains R. So I'm just going to make PR. So we're going to do the R's minus the P's. So -2 minus 4 is -6. 2 minus 5 is -3. 0 minus 4 is -4. So both of these vectors are in the plane because they were created with points in the plane. So if we do a cross product between them, a cross product always gives us a vector that is normal to the two vectors we plugged in. And since both of those vectors are in the plane, the cross product will be a vector that's normal to the plane. And I've done so many of these cross products before, I tend to skip a lot of steps. If you know the formula from physics and you've done that quite a bit and you want to just jump straight to the formula, that's fine. If you don't want to do the 3x3 matrix, that's perfectly fine. If you like the 3x3 matrix method and you'd rather do it this way, but it's still pretty new to you, I suggest you write out the intermediate 2x2 matrices as you go. Just as some intermediate work so that if you are making a mistake, if your answer is not correct, you can go back and that might help figure out where the mistake was. So if we expand this along our IJK row,
I see where I missed it.
right there at the beginning somewhere,
Yeah,
Okay. Probably just a
I
sign.
didn't get there. Yeah, I didn't get a -7.
Yeah, just a sign on one of your numbers and
Or
that throws
-3.
the whole thing off. So for the I, if we cross off I's row and column, we get -7, -8, -3, -4. And remember with J, we change signs. We get -6, -8, -6, -4. And then back to plus for K, -6, -7, -6, -3. And then for the 2x2s, we're just doing the major diagonal, that product, minus the product on the minor diagonal. So I'm doing -7 times -4 is +28, and then -8 times -3 is 24, and I'm subtracting, so 28 minus 24. And then negative times a negative is a +24, negative times a negative is a +48. Negative times a negative is a +18. Negative times a negative is a +42. So I get 4i. 24 minus 48 is -24, but remember we're subtracting the j, so it turns to plus 24j. And then 18 minus 42, is that 24, -24? Now, one thing that MyLabs Plus might be doing is simplifying this vector, because we don't care how long this vector is. We're only using this vector for its direction. And notice that all of those terms have a common factor. 2, but also something bigger, 4. No, not 11. We could technically, if MyLabs Plus doesn't take our initial answer, we could technically pull a 4 out, because we don't care how long this vector is.
So couldn't we just make it into a unit vector?
We could also make it into a unit vector, yes. That's going to throw some crazy radicals in the problem also, though. So if we want to avoid radicals and just kind of stick with whole numbers, we could factor the 4 out. We don't have to do that right now, but if for some reason MyLabs Plus didn't like our answer, that might be one of the reasons. I'm going to stick with 4, 24, negative 24 for right now. And I'm going to plug it in and see what MyLabs Plus has to say about it in just a minute. If it doesn't like it, then I'm going to switch it. So this is our normal vector. To write the equation for a plane, we need a normal vector and we need a point. And we've got 3 points to choose from. It doesn't matter which one we use. The answer will come out the same no matter which one we use. So I'm going to go back to the one that has 0 in it. Plugging in zeros is easy. So I'm going to use R, negative 2, 2, 0. So remember, our components from our normal vector are our coefficients, and then we subtract off the coordinates. So 4 times x plus 2, since our x coordinate is negative 2, plus 24 times y minus 2, minus 24 times z minus 0. That's not 0. Equals 0. And they want our answer in general form, so we distribute. And we can put the 8 and the negative 48 together to make negative 40 and move it over to the other side as a positive 40. And because there was an extra factor of 4 in our normal vector, there's still an extra factor of 4 in our answer. So notice that every single coefficient, even the constant in our answer, there's still a multiple of 4 in common with all of them. But I'm going to type this one into MyLabs Plus and see if it likes it or not. If it doesn't, it might want us to divide everything by 4. As long as we do it to everything, then we haven't violated any math rules. Oh, I can't plug it in because I'm using Kirby's account. No. But I can. Oh, it will let me type it in. I don't know. Should I type in an answer for Kirby? I think that's what we said.
Yeah.
Oh, but there's no submit button. That's why.
It's saying that's wrong.
Go to the right
Right,
page.
4x
Plus 24y
plus 24, never mind.
minus
I put a J
24z
by accident.
and j.
I put a J in. I don't know why.
J is to the one.
24y minus 24z equals 40.
It liked it?
Yeah.
Okay, good. So it doesn't care if we pull out that extra factor of 4 or not. All right, so number 6 was distance between a point and a line, and they gave us the line as a set of parametric equations.
Just plug that into this.
No, we want to do it by hand. We're exercising our brain.
So,
It makes it so we don't get dementia.
Hmm?
It makes it so we don't get dementia.
Can we do something other than this to exercise? What class is this again? Like puzzles. City.
You gotta pay for that. Oh wait, you had to pay for this too, didn't you?
No.
Adam didn't.
I had in physics. 'Cause I had
Kirby might not have. Kirby,
What about
are
the
you still
book?
considered a high school student? No.
You graduated?
I graduated in May.
So 4T, 1T, 5T.
I wish that.
All right, so this one is similar to
Right.
point in the plane. The problem is we don't have a vector automatically built into the parametric equations for a line that's normal to it. The vector that is built into our line is in the same direction as it. So we've got to create a normal vector. And what do we do that creates a normal vector?
Oh, would you use 2 points?
What operation will create a normal vector? A cross product, right? So if you want the distance between a point and a line, you're going to do cross products. So in the formula for distance between a point and a plane, we have dot product in the top. In the formula for distance between a point and a line, we have cross product in the top because we've got to create a normal vector. Okay? So we've got to get a point that's on the line. You can do that by plugging any value in for t. So somebody pick a value for t and plug it in and tell me a point on the line.
No, it has to be negative.
It's gotta, okay, so that's your t. So what's the xyz? Okay, if we plug in t equals -1, we'll have -4, -1, -5. That is one of an infinite number of points on the line. You could have plugged in anything you want. You can plug in 0, you can plug in 40, doesn't matter. Sir, sure. So now we need to connect the point that they want the distance for to the line. So we're going to make a vector, SP or PS. Doesn't matter which direction it goes in. So I've called mine SP, which means I'm going to do the P's minus the S's. Type it in the calculator if you need to. That's why we're allowed to use calculators. Don't make silly mistakes. -4 minus -2 is -2. -1 minus 8 is -9. -5 minus 2 is -7. We need the vector that's being used to tell us the direction of the line. And that we just pull right out of our set of parametric equations. 415, yep, it's our coefficients. Now with distance between a point and a plane, we would dot them over the magnitude of the normal vector. Now here, we don't have a normal vector, so we have to create a normal vector. So we're going to cross them over the magnitude of v. And what kind of answer do we get back when we do a cross product?
Another.
We get another vector, right? And we don't want a vector answer. We're trying to answer a distance question. So we need to do the magnitude of the cross product over the magnitude of v. So distance is magnitude of SP cross v over magnitude of v. So I just went ahead and did magnitude of v real quick. That's going to be our denominator. We need to do our cross product, and whatever vector we get back, we then need magnitude for it. There are a lot of negatives in this answer, and I've written all of them down. I've not tried to simplify anything in my head. So it's always the major product, subtract the minor product. And I wrote all that out. So negative 45 minus a negative 7. We can type it in the calculator. It really means plus 7. We're going to get negative 38i. Negative 10 minus negative 28, that really means plus 28. 28 minus 10 is 18. Remember, with the j, we changed the sign, so it's back to negative again. Now we're going to end up adding 36 to that negative 2, so 34k. And we just want the magnitude of this for our numerator in our distance. And in MyLabs Plus, it does say you can round it to the nearest thousandth, so we don't need to keep this exact. But I wouldn't round it until the very end. Be really careful when you're squaring negatives. Those always come out positive. And if you know that ahead of time, you could just leave the negative off when you type it in your calculator so that you don't accidentally forget the parentheses and then have it come out negative and then subtract from your other values. A negative squared will always be positive. All three of those values under that square root should be positive. Add them together should always come out to be a much bigger positive. You could just leave the negatives off altogether. And then number 7 is exactly the same. It's the distance between a point and a line. So you go through the exact same steps. That was the magnitude for V. The vector from our line, the direction vector from the line. Number 7 was the other one that you didn't have done, and that one is asking us to do the exact same thing. Gives you a point and a line, asks you the distance.
What do you mean since it's not answered? Would it take the decimal?
Yes, it says underneath in the blue parentheses, it says round your answer to the nearest thousandth.
Well, for number 7, it says required.
Oh, okay. So if you got it to this point, and they didn't want you to do a decimal, you need to think of this, since they're both under a square root, you can think of them as just being under one giant square root. And tell your calculator to just simplify the fraction. 29/24/40. Leave the square root off. So in the calculator, I'm going to ask it what 29/24 divided by 40 is. And then I'm going to change it back to a fraction. This is the same thing as 731/10.
It's supposed to be 42.
Yes. Thank you. You guys are paying attention. I'm just kidding.
Why didn't you give me an irrational number? So, but I just have to put,
Irrational, like it's got a square root?
no.
So I do the division, but then I tell my calculator to change it back to a fraction, and it will change it back to a simpler fraction. And if they want you to rationalize, we're going to have to separate it again. And we're actually going to have to multiply top and bottom by radical 21, which means they're going to get multiplied together. Oh, I hope that's not what it wants you to do. I'm going to open it back up and see. That's nasty. Let me open my ellipse plus back up real quick. It doesn't say you can put a decimal in for number 7.
Oh, I got lucky. I was 0.
It was 0? Are you kidding me? You lucky duck. Maybe everybody's a 0.
Might be. That was really nice. That was for number 7. Yeah. 0.
Yeah, so maybe that's why it's not giving rounding instructions, because it's purposely making it come out 0. Oh, that's not what I wanted.
That was so much Cantina Band. I can do anything. There's a song though, don't tell me. Oh my gosh.
Yeah, there's a reason they didn't give you good rounding instructions for number 7. There's a reason. Everybody's answer is going to come out 0. What does it mean if the distance is 0?
They're on top of each other.
The point is on the line. That means the point that they gave you is on the line.
So y'all did all that work.
Meaning you didn't do it.
Huh?
You typed it into your program.
I did not. How dare you accuse me of that? It's fake news. It's alternative facts.
Alternative facts.
The president, I have always been dedicated to doing my math without help. It's running smoothly. The grades, they're huge. They're beautiful grades. I've never seen.
Yes, that's the start of your valedictorian speech.
I know this. And I'm saying this when our principal like, Mr. Ward, great guy. I've done him a long time. He's doing great things for Mass Central. We're doing things bigly at Mass Central.
Bigly.
We are winning again. We are winning.
You gotta do the finger point.
We're winning like we've never won before. We're so tired of winning. And
Remember, you gotta do the finger point too. It does the 0, it does the okay, and the finger point.
And we're going to bomb the advice of great wrong speech.
I want to see it. I want to see a video of that.
He says it at the best times, though. Like, people have gotten to the point where they just say it at the stupidest stuff.
That's what I was about to say. What? What about 2 G's?
Well, you ain't seen that done with Rock. I told you it was working on Mars.
All right, so I stopped and I had you guys take a test when we got done with lines and planes. All of the stuff up to that point kind of naturally goes together because it all deals with vectors that have constant components. After that, we start dealing with vectors that have function components, and those are called vector-valued functions. This new textbook that we have switched to doesn't really have a good separation between the vectors with constant components and the vector-valued functions. It just kind of continues on and makes this one giant chapter with 10 sections in it. Our old one cut them into 2 separate chapters. So I didn't want to test you on 10 sections at once. I thought it was a good spot to stop and have a test on that stuff, and then we'll pick up with the vector-valued functions and have a separate vector-valued function test. Okay? So this is kind of the middle, towards the end of section 11.5 where we pick up with vector-valued functions, and this is where calculus is going to start coming in. We're going to start looking back at derivatives and tangents and integrals and velocity, acceleration, rates of change, things like that. Okay? So we just finished looking at parametric equations for a line, which we said are x sub 0 plus at, y equals y sub 0 plus bt, z equals z sub 0 plus ct. We said that is one way that we can write it as a set of parametric equations. We did also say that we could write this line as a vector and treat those individual equations as the components. Technically, this is our first vector-valued function because our components have variables in them. So x sub 0 plus at is our x component, y sub 0 plus bt is our y component, z sub 0 plus ct is our z component. And this is what keeps this three-dimensional object going forever. Typically, when we write a vector, it has a fixed starting point, a fixed ending point, and we connect them, and that's it. It doesn't keep going forever. But because we have that t variable in there, we can plug different values for t in, and this thing extends out forever in both directions. It's some never-ending three-dimensional object. This one in particular is a line because its components are linear equations. Curves in space can also be represented by these vector-valued functions. Or let me just say vectors for now. Curves in space can also be represented by vectors. The components of the vector will be functions of t. As we saw with the line, when the rate of change is constant for each of our components, it just creates a straight line. But if the rate of change is not constant, that's when we start creating some curve. So if we changed even just one of those components to a different type of function, like a quadratic function or an exponential function or a trigonometric function, it wouldn't necessarily be a line anymore, a straight line. It would start to have some curve in it. So vector valued functions, we usually call them R of t. And we're going to see R of t over and over and over again for the rest of the semester as representing a position function. And it's got components that are all functions of t, and they could be anything. For lines, they're all linear functions. As we start doing derivatives and antiderivatives, R of t is always going to be considered the position function. So when we do the derivative, what do you get if you do the derivative of a position function? Velocity function, right. So we can get velocity, and then second derivative will give us acceleration. And then if we have acceleration, we can do antiderivative to go back to velocity, and then antiderivative again to go back to position. We could also write this in the other format that we know with the i's, j's, and k's. Those two formats are interchangeable. Completely up to you, and we'll probably see both of them. Some examples of what this might look like. We're not going to do anything with these just yet, but R of t equals 4 cosine ti plus 7 sine tj. That is a vector valued function. It's a vector because we see the I and the j, but the components are not just constants. The components are functions of t. And if we wrote this in our other format, it would be R of t equals 4 cosine t, 7 sine t. So our components are functions of t. That looks fun, doesn't it? T squared plus 2ti plus 3tj minus e to the tk. A vector valued function. It could. So vector valued function, that's just two separate concepts that we have now combined. It's a vector because we see the ijk, but it's also made up of functions. Its components are functions. So it's a vector valued function. And we can see it written in either format, does not matter. They're interchangeable. But we've got a vector whose components are functions of t. So one of the first things we like to do when we first learn about functions is talk about their domain. And we're going to do the same thing here with these functions. Since a vector has multiple components, we're going to be dealing with multiple functions simultaneously. So to figure out the domain for a vector valued function, we need to figure out the domain for each of the individual pieces and see what they have in common. If we're going to plug a value into this function, it's got to work in every single component. I don't want any of my components to come out undefined or to come out as an imaginary number. It's got to work in all of them. So we want to restrict ourselves to numbers or to t-values that are going to work for all of them. So the domain of a vector valued function is the values of t for which all component functions are simultaneously defined. And probably the easier way to say that is it's the overlap between the domains of f of t, g of t, and h of t. So if you remember back to algebra class, might have been a very long time ago. We created new functions out of f of x and g of x and h of x. We did algebra of functions. We created f plus g and f minus g and f times g, f divided by g. And we had to figure out the domains for those functions. And the domains for those functions were the overlap of the domains of the two functions you're using to create them. So if we wanted the domain of f plus g, we had to find the domain for f and the domain for g and see what they had in common. We're going to do the exact same thing here, except if it's a three-dimensional vector, we might have three functions to take into consideration. So we're going to look at all three of those individual functions and their domains and see what they have in common. And that's going to tell us what values we're allowed to use for the vector valued function as a whole. As a very quick review, what kind of things do we need to consider when we're looking at domain? What things give us trouble? What kind of functions do we have to restrict the domain? Square roots give us trouble. Square roots, fractions. If we have one of our components has a square root in it, we need to make sure that our radicand is always greater than or equal to 0. If one of our components is a fraction, fractional numbers are fine, but variables in the denominator could give us problems. Why? We can't divide by 0, right? So if you see a variable in a denominator, we need to make sure that our denominator will never equal 0. So these are some of the things that we do to help us figure out what the domain of the individual functions are. These two we learn at the very beginning of algebra class, and now that we've gone all the way through precalculus algebra and all the way through trigonometry, there's a few more we could probably add to this. Logarithms. You cannot plug all real numbers into logarithms. Does anybody remember what the problem with logarithms are? You can't do negatives and can't do 0. Yes. So if one of your components contains a logarithm, the anti-logarithm, has anybody heard that word before? The anti-logarithm is the expression that's plugged into the log. The anti-logarithm must be strictly greater than 0. So unlike the square root, where you can take the square root of 0, the answer is 0, you cannot take the log of 0. There's no problem with exponential functions. If you look at the graph of exponential, it goes forever to the left, forever to the right with no breaks or holes or anything like that. There are some trig functions that have problems, and we'll talk about that if we see any. All of them are different. There's lots of different asymptotes in our trig functions. I'm going to write it down, but if we see any, we'll talk about it as we get to it. So it's not an entire set of numbers that we need to throw out with trig functions. It's usually just a single number we have to throw out with trig functions. Did you say I spelled asymptote wrong?
One day last year, I said you spelled asymptotes wrong, but I just realized I was spelled asymptotes wrong.
I'm a terrible speller. It's quite possible that I spelled it wrong too. Usually the difficult words I spell right. It's usually the easy words I spell wrong.
See, I always pronounced it last year as asymptote. You know, it's asymptote.
Oh, yeah, a P at the end? Mm-hmm.
My math 1, 2, and 3 teacher, whenever he writes it, he goes, asymptote.
That's what I say in my head to remember how to spell it.
Asymptote.
I won't ever say it out loud though.
He has all these weird sayings, like the quadratic formula. He'll sing a song.
Mm-hmm.
Yeah. And then he'll be like, if you're doing something, if you're talking or something, he'll be like, bring it on back. Bring it on back. It's just so crazy. Negative B, plus y square root, plus y square root.
To be completely honest, a lot of the math that I know is not because I just know all the math. Like I've got weird little sayings in my head that allows me to remember like relationships, and because a lot of it's just, not all of it, but a lot of it's just memorization.
Always say that, like they always say, oh, I got this like little thing I don't remember, but like
it's better if you make up your own.
Yeah, none of those have ever helped me before.
It's a lot better if you make up your own.
I don't remember when it's for. I just remember some of them getting tripped on that.
You remembered one?
I remember that, but I don't remember what it's for. I just remember that phrase.
It's to help you remember that sine is opposite over hypotenuse, because that's
okay.
the sum old hippie.
There was one of them is, one girl had a silly old Hitler caused a headache to our army.
Silly old what?
Hitler.
Hitler.
This pit is not like the version where you strip on it.
Really?
She will tell you a different version.
So the Indian princess.
Not messy.
Silly old Hitler.
Silly old Hitler.
Silly old Hitler caused a headache to our army. That one girl.
I just do the Indian princess over the top.
The only problem with that one is you have to remember how to spell it.
Sound it out.
That's why I did silly old.
But the H's are silent.
Why do silly old Hitler?
I don't know. It's just.
All right, so we're just going to do one of these real quick and then we'll go. We want to find the domain for the vector valued function. R of t equals square root of t plus 2, 1 over t minus 1, e to the t.
Take square root of 0.
Yes. You can take the square root of 0.
What does?
Square root of 0
0.
is 0.
I was trying to refer back to factorial though.
Oh, yeah. 0 factorial equals
What
1.
can E not be raised to?
Nothing.
E is. E can do anything. Whatever.
E can do anything it wants.
So the only
It's
thing.
like pi.
Huh?
It's like pi.
It's like pi? Yes. Mm-hmm. Yep. E is just a number.
Oh yeah, this is.
Mm-hmm. Yep.
2.1.
All right, so our f of t
3.14.
is the square root of t plus 2. That function will have problems. We can't plug anything we want to into it. So square roots, we can't end up with a negative radicand. It's not that we can't plug negatives into it, it's that we can't end up with a negative radicand. We need to make sure that t plus 2 ends up greater than equal to 0. And then we solve for t, and it tells us what values of t that piece is allowed to use. So this piece is allowed to use t values greater than or equal to negative 2. I got a call earlier this morning from someplace crazy.
I got an email yesterday saying I'm ready to receive an inheritance of $30,000 million.
30,000.
Wow.
All you have to do is email me.
Seal Beach, California,
So I
this
emailed him
morning.
back. I was like, oh yeah.
You'll email them back your bank account number,
Yep, everything.
social security number.
Everything.
Said how much?
30,000 million is $30 million. I was like, only like 15 people in the world have that much money anyway. Like, I'm stupid. You're gonna pick a number, pick a more realistic number.
What's 1 over t minus 1? What's the problem with that one?
1.
Can't use 1, because then it will say 1 divided by 0. We're not allowed to divide by 0. Okay? So t minus 1 can't be 0, which means t can't be 1. And then for our h of t, we've got e to the t, and there's no problems with that one. If you're not sure, you can always graph these individually and look at their graphs. The domain on the graph is what's happening horizontally, left to right. So if you look at the graph for e to the t, it goes forever to the left, it goes forever to the right.
Would t need to be greater than 1?
Nope. Nope, we can have negatives in the denominator. We just can't equal 1. We just can't equal 1. So if we plug 0 in, we'll have 1 divided by negative 1, which is negative 1, so that's fine. So we can have negatives in a fraction, we just can't have negatives in a square root. So for our h of t, we have no problems. And we need to see where this stuff overlaps to get a domain for our vector valued function r of t. And I am a big fan of graphing. If you don't need to graph it to figure out the answer, that's perfectly fine. We want to write our answer in interval notation, though. We don't want to just do set builder notation and throw all the restrictions in to the end. So the numbers I have here are -2 and 1. I need to make sure I say what's going on around those guys, because those have something weird happening. The first one, I've got to be greater than or equal to -2. So I can be equal, but I've got to be greater than it. Closed circle. Mm-hmm.
Are we gonna have to use a union thing?
I don't know yet. We'll wait and see. For the second one, t can't be 1. We have to exclude this number, but it can be everything else. And then h of t doesn't have any problems. So where do these guys overlap? What numbers can be used for all of them? At least 3 numbers? Definitely.
-2, 1, and
-2. They overlap there. This whole section. Mm-hmm. And 1 is going to get a parenthesis because we can't use 1. And then this whole section got colored twice, right? Mm-hmm. Yep. So we need to make sure that whatever values we pick, they will give us back an answer for all 3 components. We don't want any of the components to come out undefined or complex with i's in it, square root of negatives, or anything like that. If I pick a t value to plug in, it's got to give me an answer back for all of my components. Mm-hmm. But you might not have done that domain stuff in a really long time, so I wanted to review it real quick. Mm-hmm. But then once you see it, it may click.
For some reason, I was thinking mean.
Thinking of mean?
Yeah.
All right.
Class on Thursday.
Yes, we will have class on Thursday.
You say that.
I'm gonna come here and get a class.
I have every intention of having class on Thursday. A full 2.5-hour class on Thursday.
So from 1:45 to 3.
From 1 to 3:30.
Okay, we're in the room.
With-
from 3:30.
From 1 to 3:15 with a 15-minute break.
So 1:30 to 3:15.
Milo, he just resigned from Brightmore.
What?
The Uniopolis guy, he just resigned from Brightmore
Really?
because he made some stupid comments. And,
I wonder if they pushed him out.
he said it was his alone.
So on Thursday, we're going to talk about limits of vector valued functions and whether these vector valued functions are continuous, and we're going to sketch graphs and start talking about derivatives and antiderivatives. It's really, really easy. If you remember how to do them in Calc 1, then they're going to be super easy. But we'll do some examples of them because you may need a refresher.